All right, CalcC, Miss Deer, back on the mic here. I just wanted to go over some of the answers for your worksheet. For number one, when we're finding the derivative, you'll see for the first part, you have y equals 2 sine x to the fifth. There is a function inside of the function. That's our chain rule. So our derivative notation for y is either y prime or dy dx. 5 comes down in front. Inside stays the same, times the derivative of the inside. The derivative of 2 sine x is 2 cosine of x. For part B, we have f of x equals 3x minus 2 over x squared plus 4x minus 8. We have a quotient, so we get to use the quotient rule. Our derivative notation for f of x is f prime of x. We always start on the bottom, leaving it the same. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Should you simplify this? No, you are done. All right, so for part C, we have x of t. You can hear my kids yelling in the background, sorry. ln of 2t plus 8 all cubed. And one of the best parts of algebra was learning how to rewrite. So where can this exponent go? Down in front. How does that help us in calculus? Well, now we have a constant. Constants pull through because derivatives are limits. So my derivative notation for x of t is x prime of t. Constant hangs out. The derivative of ln of something is 1 over the something times the derivative of the something. So if you wanted to simplify this, you could actually cross a 2 out of everything and we get 3 over t plus 4. Were you correct here? Absolutely. All right, so for part D, we have y equals log base 4 of x squared plus 1, my derivative notation. So the derivative of log of something is always 1 over the something times the derivative of the something. This is my chain rule. Now if I were to now I need my change of base, right? So I need to divide by ln of 4. All right, so for part E, this is my fundamental theorem of calculus. So if f of x is the accumulation from 2 to x under 2t plus 1. When I take the derivative, I could take the antiderivative and then take the derivative, but I would just end up back where I started. So all that ends up getting plugged into here is I get my change of variables. Remember, this tells us that the rate of change of the accumulation only depends on this piece up here. For part F, I have r of t equals, now I don't have my glasses on, so if I write this incorrectly, I apologize, to t cubed plus 4t. My kids are still yelling, which is super annoying. Sorry about that. So my derivative, again, whenever I have e to the something, to take my derivative, I rewrite my original. So it's e to the 2t cubed plus 4t, all times the derivative of my exponent, which is 6t squared plus 4. Now remember, anything exponential, we multiply by ln of the base. ln of e is just 1. So when we have e, we don't need that piece.